Okay, so I'm going to go ahead and show you how to arrive at the product, the quotient and power rules of logarithms. I'll show you the derivation for that and then show you a quick example. Then we'll talk about changing bases, which turns out to be not largely necessary, but I'm going to show it to you anyway in case someone decides to throw the change of base formula at you. Okay, first off, what we're going to do is we're going to do the product rule first. Remember, product means we're multiplying. So to start this off, we're going to start off with a couple of expressions. Y, whoops, we're going to start off using the right tool here. Y equals, so an exponential equation, y equals b to the a, and actually we're going to start with x equals b to the c. Why? Because I want to. It really doesn't make a whole lot of difference, but so what I'm going to do is I'm going to multiply these. I'm going to take x times y, which means if I'm taking x times y, that must mean, well, x is really b to the c times b to the a, right? So what does that mean? Well, with a little bit of massive gyrations, two numbers, same base, being multiplied means we add the exponents, right? Multiplication implies adding. And now I'm going to rewrite this as a logarithmic equation. So it's log base b because, well, that's the base of the exponential. C plus a is the exponent, so that's what it must equal. And that means that we're taking x times y. So the log base b of x times y is equal to c plus a. Great, you say. That's a lot of letters. Big deal. Well, no, it does get, actually, there is a big deal to this. I'm going to go back up here, and I'm going to rewrite both of these as logarithmic equations. So this is a base b, so they're both going to be log base b, but this is going to equal c, because that's its exponent of x, and this is going to equal, right, log base b of y is going to equal a. And then, using the magic of substitution, a and c have alternate identities, right? So watch this. We then know that the log base b of x times y, I just brought this down, equals, well, instead of c, I'm going to write log base b of x plus the log base b of y. So what does this mean? It means that things like the log base b of 20 could be broken down as the log base b of, well, what are some numbers that equal 20? 20 could be split up as, or decomposed, right, as 2 times 10, let's say. Is that the same as the log base b of 2 plus the log base b of 10? Turns out it is, yes, and we'll look at some examples where that works out. But that is the product rule. The log of two things being multiplied equals the log of the first thing plus the log of the second thing that you can break it out in, okay? And the quotient rule starts with the same premise. X equals b to the c, I believe it was, and y equals b to the a. And also, I'm just going to go ahead and write these right now. That implies that we're looking at the log base b of x equals c, and this is the log base b of y equals a. And what I'm going to do, so this is like our starting point, this is like our given statement, remember proofs, right? So what I'm going to do is I'm going to divide these now. I'm going to take x divided by y, which means I'm going to have b to the c over b to the a. And now applying the magic properties of exponents. Two numbers being divided means that we're subtracting the exponents. And then I'm going to rewrite this in log form, which would be the log base b of, well, there's my exponent, c minus a, so that's what's going to equal, I think you can see where this is going, I hope, of x over y, which means that the log base b of x divided by y is, well, c minus a. Wait, c is log base b of x minus a, which is the log base b of y. What does this mean? Well, this means that the log base b of, let's say, I don't know, 40 over 3, I'm just pulling numbers out of the air here, could be decomposed as log base b of 40 minus the log base b of 3, right? Nope, that's it. Quotient rule. Quotient, that means we're dividing. Let's go ahead and label these, right? So this is the product rule, right? Product rule. where multiplying gets broken out as addition. And then the quotient rule. Where dividing becomes subtraction, right? Those are how those are linked, okay? And next comes the power rule. We'll go ahead and write that down. Power rule. And I hate to say this, it's a pretty powerful rule. But in any event, let's take one of those. X equals, what was it, b to the c, right? Which, by the way, means log base b of, x equals c. And what we're going to do, this is our starting point. What I'm going to do is I'm going to take x equals b to the c, and I'm going to raise it to the mth, that's right, mth power. Okay? All right. So that means x to the m equals, well, how do you simplify this? X to the m equals, power to a power means we multiply. I'm going to go ahead and write this as b to the mc, so m times c. I'm allowed to switch the order. I am. And you'll see why in a sec. So just like before, what we're going to do is we're going to rewrite this in logarithmic form. So it's a log base b. It's going to equal m times c, so of x to the m, right? And just like the last time, I don't know if you've noticed a pattern here, we have the log base b of x being raised to some power m is equal to m times c has its alternate identity, like Batman, right? Log base b of x. Great, you say. Why is this called a power rule? Well, m is a power, isn't it? Yeah? So what does that look like? It looks like m as a power looks like you could bring it down in front as a multiple. So what that means is if you're looking at something like the log base 2 of, I don't know, 8 cubed, you could think of that as, well, this power, right? Power, see, 8 cubed. See it? See it? Yeah. 3 times the log base 2 of 8. That might be an easier problem. I don't know, right? Oh, wait, that is an easier problem. Log base 2 of 8 is, 2 to what power equals 8, so that'd be 3. 3 times 3, that'd be 9. Yeah, right. But in any event, that's what the power rule is. This is a very that's horrible. Very powerful rule because it is the easiest way to solve logarithmic or exponential equations using logs. Now, that being said, there is such a thing called the change of base formula. So back in the day, we didn't have calculators that could do the log base of any base. Desmos can, right? We used to have calculators that could do log and natural log, and that was it. Which means that if you were asked to solve an equation of a different base, you had to use something called the change of base formula. So let's say we had the log base 2 of 17 equals x, right? So what does this mean? This means that we couldn't directly just type this in the calculator like we can now and come up with an answer. So these are the gyrations we had to go through. Well, first off, we could rewrite this in exponential form. Log base 2, that's the exponent, equals that, right? And because we only had the log of the natural log, and I'm going to split this up and we'll do it both ways, I could take either the log or the natural log, whatever you felt like, because honestly, it doesn't matter. The only advantage would be that ln is 2 letters and log is 3 letters, but hey. But I had to do it to both sides. So I take the log of 2x, right, equals the log of 17. Remember, in algebra, all's fair and love war as long as you do the same thing to both sides, right? Log of 2 to the x equals natural log of 17. As long as you're consistent with what's base logs, right? And the only reason we're sticking to this is because, well, frankly, we don't have any choice. Now, this is where, without something like the power rule, which means I could bring this down, right? Same thing here. With the power rule, this is equivalent to x times the log of 2 equals the log of 17, or x times the natural log of 2 equals the natural log of 17. Now, if we're trying to solve for x, which is ultimately what we're trying to do, figure out what this exponent is, x is equal to what, right? Then that means that you could what? Divide both sides by the log of 2, so it's a log of 17 over the log of 2, or right, x equals the natural log of 17. I mean, I kind of favor the natural log because it is a little bit less writing, at least, right? divided by this. Now, this is only if you've got something that can't take the log or natural log of, I'm sorry, can't take the log of any base, only can take common or natural log. Now, there are examples out there that still exist, things like your phone calculators. Even when you turn them on their sides, right, they can only do logs or natural logs, and that's it. Why would this be useful? Or how would this be useful? Well, simply put, if you were asked to take the log base 5 of 627, right? The heck does that equal, right? You just use a change of base formula. So it could be the common log, if you're a common log person, over the log then of the base, right? Or if you're a natural log person, you do the same thing. The natural log of whatever you're trying to take the log of, then divided by the natural log of whatever the base is. Either way, you get the same thing. All of these are equivalent. That's what the change of base formula is. So if that ever gets mentioned, that's what they're talking about. Is it necessary? No, if you can take the log of any base, right? But there they are, folks. The quotient rule, the product rule, the power rule, and even the change of base formulas, even though I'm not a big fan of the change of base formulas.